Hello and welcome to our next video on logarithms, and in this video we're going to have a look at our log laws. So here we go. The log laws are basically the log version of what you know of laws of indices. So let's start by looking at our laws of indices. So there we go, there's a statement. We know 10 squared equals 100, we know 10 cubed equals 1000, and we know that 10 squared times 10 cubed will become 10 to the power of 5. So we know that when you're multiplying with the same base, you add the powers. Basic stuff, all fairly straightforward. What we're going to do is take that and translate that into the logarithmic version. So here we go, there's our statement, equivalent statement using logarithms for that one. And there's the log to the base 10 of 1000 is 3. And then log to the base 10 of 10,000 is 5. And straight away you should notice what's going on here. Yeah, there's the 2, there's the 3, there's the 5. Let's just unpick this a little bit. So what we've got is log to the base 10 of 10,000, and I've just written this here as 100 times by 1,000. The 5 there, I've just split that out and written that as 2 plus 3. So what we've got is log to the base 10 of 10,000 is log to the base 10 of 100, which is 2. Log to the base 10 of 1,000, which is 3. This thing here, log to the base 10 of 100 times 1,000, is the same as log to the base 10,000, which is 5. So this thing here on the right hand side has just got a value of 5. That's the 2 plus 3. So essentially that is exactly the same as what we've got over here, just restated for logs. And if we just take that and generalize it now, let's have a look what happens. So if we take x to the power a equals m, and there's the equivalent logarithmic expression. Take another expression, x to the power b equals n, and its equivalent, and say, okay, there's our version using index laws. And I'm just going to pick out that bit there and say we've got x to the power a plus b equals m times n, because we know this thing here is m, this thing here is n. And if we take this statement and now rewrite this using logs, we've got log to the base x of m times n equals that bit there, a plus b. And we know that log to the base x of m equals a, so that bit there, I'm just going to replace that there, and clearly for b we're going to do the same thing. So this statement here, I'm going to rewrite like that. And so basically what we're saying is when you're multiplying two numbers in the log, it's the same as adding the logs. And that's our first log law. Okay, so what we do essentially, kind of when you get further down, you can start splitting up a single log, writing it as a product, and splitting it into two separate logs. And that is just simply the log version of our addition law for indices. So there's our first law. Log of m times n is the same as log m times by log n. You'll notice I've kind of removed the base there, because these laws work regardless of what base you're working with. Now, the flip side of that one, the division version, there it is exactly the same, and as you might expect, what we get is that. So, very simply, law number 2, okay, the rationale for it is exactly the same as what we saw on the previous screen. So, log m over n is log m minus log n. So that one's our law number 2. This one is the really useful one. This is my personal favourite. I know that sounds really sad, but it's incredibly useful for solving equations where you're trying to find the power. So if we take log of m to the power of x, so we've got that there and we've got a power here. So what we're going to say is, well, that is log m times m times m times n times m, and so on and so forth. So we've got x lots of those. And now here's the clever bit, because using our first law, using this law, we can take this single log and write it as a whole bunch of separate logs, and they're all going to be log m's. So I've got log m plus log m plus log m log m, again using our first law there. How many of those things have I got? Well, I've got x lots of log m, so this whole great string of things here I can simply write as x log m. And this one's incredibly useful because I see this as kind of, taking a power and kind of plucking it out of the sky and bringing it down into the equation, and now you can start manipulating it in a much more easy way. So that one is fantastically useful, and we're going to call that one law number 3. So those are the biggies. There's some other bits and pieces which quickly mention now, but those are really the ones that you need to know, and you will end up knowing them and using them. So special case of those, we saw log to the base a of 1 equals 0, since any value to the power 0 is 1. That one we've already seen in the previous video. Log to the base a of a is 1. And then this one's a little bit on the sneaky side, and it's kind of fairly useful because what we've got here is log to the base a of 1 over x. So like if we're taking the log of a fraction, what we can do is, using our law 2, is just break it out into two separate logs. And then using the statement that we've got up here, we know that this thing, there you go, is 0. So that becomes minus log to the base a of x. So fractional stuff we can write as the negative version of the denominator. Alternatively, that's one way of looking at it. You could also do it another way. So if we just take that, start with the same points, we've got log to the base a of 1 over x. And if we write 1 over x as x to the power minus 1, and now we saw previously using law 3, let's bring that minus 1, bring it to the front, and we've got exactly the same thing. So sometimes when you're writing fractions, so logs of fractions, it's much easier just to kind of break them out and write them as the negative log. Okay, so let's just have a look at a couple of simple statements that we can rewrite as single logs. So we've got 2 log 3 minus log 1/5. So here we go. What can we do with them? Well, this first one here, we can rewrite that using law 3. There we go. So that's going to be log of 3 squared. And then log of 1/5. Again, think about the last thing we saw on that previous slide, gives us minus log 5. Okay, using that special case we looked at before. And so we've got this thing here is 9. We're going to end up adding them. There they are. And so that whole thing will simply become log of 45. So what we're doing is just can combine those two logs together, write them as a single log. Second example, here we go. So what we're going to do is take that 1 there and write that as log to the base 4 of 4. The reason we're doing that is so we've now got that one, that thing, and that thing all in terms of the same base. So there's the other two bits. And now let's just combine those together using a combination of law 1 and law 2. There we go. So that just becomes log to the base 4 of 3.